So not that long ago, I made the lightning tree, the first version of it, and it's essentially just like a little art piece that is attached to a high voltage music player. And when I first built it, it was in pretty good shape and it looked like this. But then after a while of, high voltage arcs and adding fire and playing around with it, it ended up looking like this. So because of all that wear and tear, I realized I needed to build a new lightning tree that was able to resist the wear and tear of, high voltage arcs and fire, because I feel like those are two things that I can't eliminate from this design. I built the second version, and in this video, I'll show you how I went about doing it. So this is the lightning tree 2.0. It's essentially resistant to high voltage arcs. As well as being exceedingly good at being fire resistant. So this actually started as a 3D printed item. If you look at the layers in the tree itself, you can actually kind of still see some of the 3D printed layers on there. I kind of like that look. But now it's made of solid aluminum, and I'll walk you through how I took a 3D printed object and turned it into solid aluminum. And this was actually very challenging to do because the branches are so small that getting the details to cast properly was a bit frustrating. So let's see how I did it.
Alright, so let's make the lightning tree 2.0. I 3D printed this tree. So first I'm going to make the shape of the outside of the mold using this mesh wire to help hold all of the plaster and sand mixture into a good rigid structure. So here's the structure of the mold. So the plaster Paris sand mixture is going to pour on top of here. I'll probably just put some aluminum tape or something around the outside. So first step, surround this in tape, cover this in plaster Paris, and then I'm going to have to bake it to get all of that material burned out of there. Here I have it wrapped up, and then I have put a glue stick on top, and that's just for a pathway for the aluminum to flow once we go to pour it in. What I'm going to do is I'm going to fill this with that plaster Paris sand mixture, and then I'm going to let it harden. Then I'm going to bake out all the 3D printed material on the inside. I'm going to try to vacuum seal the crevice that's going to be left inside the middle, put an aluminum layer on top, and when I pour the molten aluminum on, I'm hoping it'll just suck in into the vacuum inside into that crevice and fill all those little branches and everything so I can actually get all the details. That's the goal. I really don't think I'm going to get all the branches with the casting, but I'll give it a try. It's a good test. So to make the mold, we start with plaster of Paris, and we're going to cut it pretty much 50-50 with some of my casting sand that I use for the aluminum casting. So this is just like a clay fine sand mixture. So I'm going to take some of this, and I'm going to mix it in with that plaster of Paris, then add the water, and once it's all mixed together, I will pour it into there and let it set. Okay, so I got the mixture here, so I just pour it on top, and here we have the final assembled. Right now inside of here, there you see that little glue stick sticking up. This will probably sit in here overnight. Next step is going to be to actually bake this so that all that 3D printed filament on the inside, as well as that glue stick, all burn out of it or melt out of it. Then what I'm going to do, I'm going to make it so I have a little bowl shape on there as it starts to harden. It's starting right here. Let's let it set for a few minutes first. And then I'm going to cover it with tin foil and hopefully be able to put this in a vacuum chamber and seal it. So when I pour the molten aluminum on top and it gets sucked right in, and it's going to fill with the liquid aluminum from my induction heater smelter, and I'll have a brand new lightning tree. So I got this baking in my really janky looking oven here, and this baking process of the mold is going to do two things. First is it's going to remove all the moisture from the mold, because when I put it in the vacuum chamber, the moisture or water will boil in a vacuum. So I want to make sure I don't have any pockets of steam or vaporized air rapidly expanding inside the mold, which could cause damage to it. Second thing that it does is it melts out all that 3D printed material, and it makes it so that the mold is hollow. So when I put it in the vacuum chamber and seal it inside of there, the crevice inside is in a vacuum, so it pulls the aluminum right in exactly into all the little crevices. That's the idea here. It's been cooling for a few hours now. Well, it looked like it started melting out. So you hit the sand and solidified, so I'm probably going to have to bake this thing some more. Maybe elevate it a bit so the 3D printed material can kind of run out. So essentially here what happens is this is all going to burn off when I pour the aluminum onto it. I just got this kind of hot glued onto there for now, just to put this into a vacuum. Hopefully it holds. If it does work, I'll bring it over to my aluminum melter and we will get casting. Okay, so pull it into a vacuum.
As soon as the molten aluminum was poured on top of the mold, it did exactly what I hoped it would, and it melted the top and sucked inside and filled all the little crevices and holes. For that, I got to do one of the funnest parts of this whole thing, and that is carefully excavating for the lightning tree inside the plaster of Paris mixture. This went really well. Only one branch actually ended up coming detached, and I was able to reattach it later with aluminum brazing rod. Overall, I am really happy with how this thing turned out. I think it looks stellar. So one more thing I'm going to try to do is take away some of the aluminum metallic look, and I want to see if I can add like a darker kind of a tree kind of color. So something I can do fairly easily is actually copper plate this, and I'm going to do that using copper acetate. So we make copper acetate by combining 50-50 mixture of hydrogen peroxide and white vinegar. This mixture is heated typically in a microwave, and then a copper scratch pad is added and little bits of copper dissolve off the scratch pad, turning the mixture light blue color. Next is grab a sacrificial copper anode, and this is going to go down in the copper acetate and attach to the positive side of a power supply, usually something between 3 to 6 volts, somewhere around there. And the negative side of that same power supply is going to attach to whatever workpiece it is that you want to copper plate, in this case the lightning tree. To evenly coat it, we're going to want to dip it several times and agitate the copper acetate. As we're copper plating it, constantly checking to see if the plating is even. So after a few coats, it's starting to get a bit of that kind of coppery sheen to it. I'm just trying to darken it up a little bit just so it kind of has that kind of wood look to it. Yeah, I'll probably do a few more coats and we'll see how it turns out. The copper gave us a really nice kind of reddy, kind of rustic look, but it was a pretty bright color compared to normal wood colors. So to darken it up a bit, I settled on using dry graphite spray, which is normally used for lubricating machinery, but in this case it works really well for the lightning tree because it's electrically conductive and I can copper plate on top of it. And I can alternate back and forth between copper plating and the graphite spray until I get my desired color. So after a few coats of copper plus a little bit of the graphite spray, I successfully got a pretty good color going. So none of this is paint because of the heat this thing will go under. So this is just from the copper plating and coating it with some of that graphene powder, and this is how it turned out. So old spooky tree looking. So let's get it set up inside of the lightning tree assembly. So the bowl at the base of the lightning tree needs to be a really good electrical insulator. I decided to scrap the previous one and make a new one from scratch, which involved using the glass drill bit to cut holes in the bottom of both the bowl and the glass sleeve, which is really just a candle holder from the dollar store. And then again, using epoxy resin, as it is a great electrical insulator, to combine all the parts together, run the high voltage leads through, and kinetic sand. Inside of the base, I like the green color to make it kind of look like, nature, because nature likes green, I guess. And then we add some mineral oil to insulate the little gaps between the kinetic sand, as well as insulate the base of the tree just to prevent arcs from jumping up from the bottom. For the first lightning tree, I ended up using water down at the bottom, and I'd add things like steel wool and sometimes other stuff that was flammable, like I did here. And in this lightning tree, though, I wanted to add something different, and I thought sand would look really cool, kind of give it a desert feel to it. And I think it turned out really cool. Sometimes I want the arcs to actually jump down to the sand, though. So to make the sand more conductive, I added black iron oxide. And black iron oxide is electrically conductive, so mixing this in with the sand gives it a little bit of a darker look. Plus, it makes it a little bit conductive. I don't want to add too much, but just a little bit around the edges just to make it so the arcs sometimes jump down into the sand. Looks pretty cool.